Science is equal parts creation and discovery. Recent advances in neuroscience have shown that our brain is and always has been a dynamic organ, constantly changing as we move through life. The brain of every human changes itself through neuroplasticity. Scientists have now uncovered ways to harness this powerful ability to achieve radical transformation in the lives of people everywhere. Join us as we explore the incredible promise and how scientists, technologists, psychologists, and medical doctors are creating solutions and changing people's lives in previously unimaginable ways. Science is poised to change the way we learn, the way we age, and the way we heal on the cutting edge of brain fitness frontiers.
There had been a long-standing idea that the adult brain just cannot change in any fundamental way. But then there began to be studies that suggested, in fact, that dogma was completely wrong, and it just opened up a world of possibilities.
Using the brain's own ability to change is called neuroplasticity. And neuroscientists are pushing the boundaries of what was once considered the realm of science fiction.
And neuroplasticity provides a basis for what we are. Because each time we acquire a new skill or a new ability, each time we learn some new thing, each time we improve our ability, we're actually changing our brain. Our brain is plastic. It's constructed to change. And the accumulation of those changes really define who we are, what we can do, what we can't do.
We do know that the brain is an organ that's designed to change. The brain is an organ that's designed for plasticity. So we hope that using its own capability, it may be possible to change it in quite dramatic ways.
Everything that we do, everything that we learn, every experience we have changes the way our brain works.
In order to better understand the function of plasticity within the brain, neuroscientists utilize the latest tools in brain imaging. Techniques such as functional magnetic resonance imaging, or fMRI, have opened up entirely new understandings of the physiological transformations of the brain. Scientists at the Wellcome Trust Centre for Neuroimaging undertook an unusual study to better grasp the function of a part of the brain called the hippocampus.
The hippocampus seems to be very central to memories in general. The reason for that is that its connections with the whole of the cortex.
On the hippocampus, we're hanging our memories on a curtain of time and place. We're constructing a world in which we locate things in our three-dimensional realm. And we're also constructing things in the complex domain of the passage of time.
Dr. Frakowiak and his colleagues were interested particularly in visual memory and its relationship to the hippocampus. To explore this association, they had to find the right test group. After much searching, they discovered the perfect population was right outside their door.
We were talking about memory, and down the road were coming these little scooters with plexiglass fronts with a map. And these are guys who are training to get their taxicab license.
When you're on the knowledge of London, the way you study the streets of London is you physically go out on your moped following a set route. And then you have to learn that set route. You have to commit that set route to memory. And obviously the best way to do that is to call over.
London Business School to the Thistle Selfridges Hotel. Off you go. I want the call.
Yeah. Okay.
Go.
I'm going to leave this on my right, Sussex Place. I'm going to go right into outer circle. Leave it by.
In fact, they're learning the whole geography of London. And then suddenly, click. My God, visuospatial memory. These guys have to remember things in space, relations in space. They have to remember routes. It appeared that we had a captured population. And we had people who were at various stages of learning about the geography of London.
Okay.
When someone studies for the London taxicab driver's license, they're said to be on the knowledge. That achievement involves spending sometimes 7 days a week for 3 or 4 years, recording the street directions and geography in the incredibly complex metropolis that is London.
So basically what we've done from Devonshire Street, we've used Devonshire Place Mews to cut through to Marylebone High Street. Okay?
And at the time, we were just introducing into the lab a new technique for analysing brain images. Would it be possible that taxi drivers who spent at least 8 hours and probably more per day finding their way around a very complex environment would actually, through time, change the structure of their brain? A real form of plasticity, environmentally driven.
Neurologists know that a critical area in the back of the hippocampus is specifically related to orientation.
If you get a stroke in this area, you just wipe out your memory for space. You lose yourself in your own home. For these experiments, we were hitting on the same area. And so it became clear that that was firstly a critical area for this type of memory, but secondly that the environment seemed to be playing a role. We made a correlation between how long you'd been in the profession and how large this part of the hippocampus was on the right side. And it was a clear relationship. The longer, the bigger.
It's always nice to know that I've got something bigger than everybody else has got.
But size isn't everything. Brain structure volume is only a fragment of the whole story.
I think we've gotten very comfortable with talking about individual brain areas, particularly since the advent of fMRI, because it's like, oh my heavens, look at that, that's lit up, that's exactly where it's going on. But we really need to remember that the brain is very interconnected and that there's lots of information moving back and forth. That's true for the hippocampus also. I mean, you can have memories even if you destroy most of the hippocampus.
Further insight into memory was uncovered when that very event occurred.
So there's this guy who was one day found wandering along the side of the highway, and the state policeman who picked him up asked him his name, and he gave his name and said that he was stationed at a nearby army base and gave his age as 22 years old. And I don't know if the officer realized it or not, but he must have appeared at least a decade older than that, because he was. And he didn't live at this army base anymore, although he had been stationed there when he was about 22. And it turns out that he had just lost all of the memories of the last 11 years, gone. He didn't remember that he had had 2 kids. He thought that his wife was still just about to have the first kid. And he had no memory of the second child, no memory of his post-military career, nothing. And it turned out that he had a cyst that was pressing on the conduit between the hippocampus and the rest of his brain. Once that cyst was drained, all of his memories returned. What this is a really rare living example of the most interesting thing I think about the hippocampus and memory, which is that for memories that are what they call declarative, meaning memories that you can talk about, what I had for breakfast or where I was born, these memories are initially brought into the hippocampus. It is only after time that they're sent out to the cortex.
As with the Wellcome Center's study, neuroimaging processes help unveil some of the secrets of brain activity. A group of researchers led by Dr. Christopher Descharmes are investigating the use of real-time fMRI to help patients suffering from debilitating chronic pain.
We have been studying chronic pain patients, and we have asked the question whether a patient can learn to control the areas of their brain that produce pain and the areas of their brain that turn off pain, and thereby whether they can learn to control their pain experience itself. So the way that we do that is that we present the patients with images, with ongoing video, live video from inside their own brain, as it were. And we ask whether they can learn to control the processes in their own brain that make the pain go up and make the pain go down. And if they can, we hope that they're going to be able to control their pain itself.
Dr. Descharmes and his team are developing a new strategy called neuroimaging therapy that attempts to accomplish this task.
Neuroimaging therapy is the approach of measuring the brain's activation in real time, live action, second by second, and presenting that information to a person or a patient so that they can try to learn how to control and understand their own brain activation.
Watching the brain activation allowed the researchers and the patients to gain insight into what mental strategies could be used by that individual to control their pain.
While the patients are in the scanner, they watch through goggles images, computer displays of their own brain activity, but we don't show it to them in a way that looks like a brain. We show it to them in video displays that look intuitively understandable. So for example, we may take brain region corresponding to pain, and when the region's activity goes up, we show a flame getting larger and larger in video. When the brain activation goes down, we show the fire getting smaller again. The reason we do that is we want the patient to be able to have a realistic and intuitive depiction that allows them to quickly understand what's happening in their brain processes.
As the patient learns to control the flame on screen, they are also learning to control their own brain, targeting and driving their plasticity to control their pain.
We think it's possible that strategies that produce short-term changes in pain, moment by moment, could be different from the strategies that produce enduring changes in brain activation and in pain. And that's one of the reasons that being able to see the brain processing that's happening, as it were, behind the curtain of pain may allow people insights in how to control their own pain.
Chronic pain is a disorder that destroys the lives of millions of people in the United States and worldwide. Most patients who have chronic pain never find adequate relief from the existing medications and existing treatments.
There's a built-in dial, as it were, in the brain that when you turn it up, the pain goes away. And so we hoped that we could teach people to control these brain systems, to take control of this dial for themselves and make their pain go down. One of the key aspects of plasticity is that activation in the brain that's repeated again and again and again produces enduring change. You can use the metaphor of a river carving through a valley till you get a deeper and deeper valley and eventually a canyon. Well, chronic pain is potentially one of the most extreme cases. If you have pain that's going on moment after moment, day after day, and the same process is being activated in the brain repeatedly, you can produce enduring change in the brain.
When you have chronic pain, you don't think about it, but actually you're in a learning mode about your pain. Pain is very important to you, and the brain wants to know about things that are painful. The more important it is to you, the more you learn about it and you grow it. And after a while, it's grown to such an extent that you don't really need to have the present pain in order to feel it. And some people historically would say, well, that's mental, but it's not mental. It's actually physically changed your brain through learning. You've learned to feel continuous pain.
One of the things that's very challenging for many pain patients is they say, my family doesn't believe me. My physician may not believe me. I'm not even sure I believe myself because I've had this experience of pain for so long, but there's no physical manifestation that anyone can see. By looking inside their brain, they feel, many patients have told us they feel very empowered by being able to see potentially the physical substrate, the physical cause that leads to their pain. We hope that we can take that process of plasticity that carves pathways in the brain and reverse it or change it, and that we can produce enduring changes in the brain's pathways related to pain, the pathways that produce the experience of pain. And by changing those pathways, we can change the clinical experience of pain in patients, and that can be a long-term enduring change for them, we hope.
While this work shows enormous potential for the future, the research is ongoing. Dr. Descharmes and his researchers are at the forefront of neuroimaging therapy that may one day answer some of our most pressing questions about the intersection of brain and mind. Other research focusing on the thousands of victims of balance loss, sometimes called wobblers, uses neuroplasticity to address the loss of the vestibular system in the brain.
4 years ago, I had viral meningitis and encephalitis. I was in a coma for 10 days. I almost died. And I was in the hospital for a month and then came home and learned how to do everything all over again. And went for balance testing and found out that I had lost the vestibular system on the right side of my body.
The vestibular system is a part of the brain in combination with the cochlea that comprises the labyrinth of the inner ear, which contributes to the perception of self-motion, head position, and spatial orientation relative to gravity.
The best way that I can describe it when you're standing and you have a vestibular problem is it's like being on a boat in the middle of a lake. When you're sitting, it's almost like when you have windshield wipers on in your car and they need to be changed because there are too many streaks.
Researchers at the University of Wisconsin-Madison, led by the late neuroscientist Paul Bach-y-Rita, pioneered a breakthrough therapeutic device harnessing the power of plasticity to address loss of balance. This research led to the development of the BrainPort balance device, which converts information about body position into electrical stimulation on the tongue.
When you use the BrainPort, it provides that information for you. So you get trained to use that information as if it were your vestibular system.
What you would do is you would take a piece of plastic about the size of a piece of chewing gum that had about 100 different little dots on it, which were electrodes. And you'd put it on your tongue, and they'd give you the tiniest shock, so that when you tilt it forward, you would feel as though there were champagne bubbles on your tongue, sort of running to the front part of your mouth. Then when you tilt it back, they would move back, and to the left and the right, and so on.
A user of the BrainPort balance device trains their brain to understand where they are in space and eventually help them restore normal balance. The researchers found that this effect continued even after the user stopped actively using the device. This created a residual effect, which allowed the patient to lead a more normal life.
I walked in with the cane because that's what I needed so that I could compensate for no balance on the right side. And after several days, I didn't need the cane anymore. And my youngest daughter, who was in Ecuador, had called to find out how I was, and I had told her that I no longer needed the cane, and she started crying on the phone.
Vestibular problems are not limited to just the thousands of wobblers. Balance issues are of tremendous importance to an aging population. Recent surveys in the New York Times have shown that the elderly are more afraid of falling than being mugged.
When we walk, our brains are very, very actively involved in processing us and orienting us. Older people will often be watching their feet as they're walking down the stairs. And because it's a use it or lose it brain, that may not be the best way to go about things, because as you start to rely more on your vision for your balance, you're not using your actual balance system.
As we've seen, plasticity can be used for powerful changes, or positive plasticity. Sometimes in the older brain, the exact opposite can occur, and we witness the ravages of negative plasticity.
If I fall when I'm older, and I realize I couldn't stop myself from falling, I'm really worried about it. So what do? The first thing I do is I turn my head down. I start watching my feet. That's a very negative step. First thing that's bad is that I've used my organ of balance from the beginning of time in my life in this position, and I get pretty good information in this. This is where I'm an expert. Now I'm watching the ground, and if somebody bumps me because I'm looking in near vision, the ground sweeps past me like lightning. So as soon as I'm bumped, my eyes tell me I'm moving over, and they carry me right to the ground. What I'm saying is you actually learn in lots of ways, inactively, to drive things negatively so that you're less capable, so that you're less versatile, so that you're less agile mentally and physically.
The principles behind neuroimaging therapy and sensory substitution devices utilize the power of the mind to change the brain. On the frontier of brain fitness, in the lab of Dr. John Donahue at Brown University, scientists are actually working to physically and directly hardwire the brain to the external world with the brain gate, pushing the boundaries of the possible.
BrainGate is a type of neural interface that is designed to restore communication and mobility between the brain and the outside world for people who have tetraplegia or paralysis. What BrainGate does to take signals from the brain to the outside world is it starts with a tiny sensor, a tiny chip about the size of a baby aspirin that's implanted onto the surface of the brain. That picks up neural signals called action potentials, and these electrical impulses come outside through a plug on the head currently that goes out to a cart full of electronics that processes the signals and interprets them or decodes them and transforms them into a command signal. And the simplest one is you think about moving your hand to control a mouse, say go left or go right, and those signals come out of your brain and the computer interprets them as mouse commands for a computer, and a cursor on a screen goes left or goes right.
Using this technology, Dr. Donahue has made it possible for someone with tetraplegia to actually control a computer. His studies, using direct connection to the brain with technology, continue to delve into how the brain can change its own abilities, its plasticity.
And we expect the brain will learn how to transform itself to better control that small number of neurons that we're requiring to perform all these complicated functions. This will be essential when controlling something as complicated as a robotic arm, for example, that has all kinds of motions possible. What can you really do? Can you learn to control these complicated functions by changing your brain?
The Brain Gate is a unique device as it merges technology and the brain in a surgical process, keeping large computer technology external to the patient. But as Dr. Donahue moves forward in his research, he envisions an even more incredible future.
What we're trying to do is come up with the brain phone, in a sense. The brain phone would mean that we take all of that cart of electronics and all of the necessary automation and processing so that a person with a Brain Gate device could literally go anywhere in their wheelchair and carry the whole system with them.
The same futuristic thinking is driving research in Ed Boyden's lab at the Massachusetts Institute of Technology as he explores the possibility of the emerging technology of light therapy.
The brain is not just a single homogeneous system. It's got many circuit elements, many neurons that project from one part to another and are wired in a very complicated way. And what's important to realize is that we have to find ways to modulate one circuit in the brain, the one that's having trouble, without altering the other parts of the brain that are normal. We and many other groups have started to be very interested in neuromodulation therapies, the use of light to turn cells in the brain on and off. Our technologies are being used by a group at Case Western Reserve University. And what they're doing is they're finding ways to take spinal cord injury models and to optically modulate neurons in the spinal cord. If they optically modulate neurons below the fracture, they can restore breathing patterns. So they think that this works by using light to modulate neurons is engaging the natural plasticity mechanisms in the spinal cord that are dormant. But if you drive activity in the right pattern, then you can get recovery of those patterns of activity, and they sort of start creating the rhythms of breathing by themselves, even though they don't normally do that.
Dr. Boyden's team discovered that the breathing circuit actually continued to work, even with the light therapy disengaged, showing the amazing power of plasticity.
Plasticity is a very important feature of the nervous system, and I think a lot of the therapies that we'd like to develop will engage the natural plasticity mechanisms in the brain rather than trying to simply replace them.
Both the Brain Gate and the optometrics in Dr. Ed Boyden's research are still in the very earliest stages of discovery, but their work holds a great deal of promise for the future, incorporating newer technologies and the power of brain plasticity. Today, positive neuroplasticity can create real and immediate changes, even with something as seemingly insurmountable as a stroke.
I was in medical school in Mexico City. I got a call and they said, come get your father. He's had a stroke and he's in very bad shape. My father had drive. He was not going to sit still for it. And he trusted me. And I said, we're going to do something about this. I don't know what, but we're going to do something about this. The only model for learning how to walk was the first model. Children, I said, this is what you did when you started to walk the first time. Let's see if you can do it the second time. And there was also a practical side. My father just hated being dependent. He could not tolerate being dependent. First, he was on his elbow, really, because he couldn't straighten his arm out properly. But after a while, he was crawling on hands and knees. And he got to the point where he could crawl up the stairs. Little by little, things came back. The more he struggled with it, the more came back.
Pedro Baquirita was basically cured by his therapy with his son George. He remarried, returned to his role as a professor at the City College of New York, and enjoyed a very active life.
Well, when you have a stroke, you have a hole in the machine. And the extent to which you have a hole in it, if it's physically damaged, you can't recover that. I mean, that's lost. But the brain has a remarkable ability to compensate, to put activities that were represented in that location in a new location, or to compensate by changing the behavior in a way that it still works, even though it's not done neurologically in the identical way.
Baquirita had such remarkable success with his therapy because he put his focus not on the skill, like walking, but how the skill was acquired, the learning process. That is how change takes place in our brain, through new skill acquisition. But it has to be the right type of learning to direct positive plastic changes. Positive neuroplasticity pushes the boundaries of what science expects with the outcome of a stroke. And when it comes to other extreme injuries to the brain, positive brain plasticity approaches can also have a tremendous impact. For instance, with victims of traumatic brain injury.
The phone rang around 6:20, and I looked at caller ID, and it said Fort Campbell, and I knew, So I just said, "John's my son, is he okay?" And he said, "Ma'am, there's been an incident."
Well, I remember running up to a Humvee to start unloading it, and all I remember was falling down, and I thought I smacked my head on my rifle. When I got up, I wiped my forehead, and there was a little bit of blood on it. And I guess the mortar round had exploded about 5 feet away from me, and shrapnel had gone straight through my helmet and straight through my head.
John Barnes' affected arm had almost no dexterity with his fingers and a greater loss at the shoulder and elbow.
And there was almost nothing that he could do with the arm.
If you constrain the good arm so that the patient doesn't rely on it, but instead through intensive therapy, which is about 8 hours a day, 5 days a week for a couple of months or more, but just encourage and coax and urge that patient to use the seemingly paralyzed arm, which sounds paradoxical, but they can. They can make tiny little movements, and if they build on those, they can regain function.
Neuroplastic change requires constant commitment and repetition to be enabled. Undertaking the Taub therapy requires commitment on the part of the patient and the caregiver. Utilizing the constraint-induced therapy had similar success with another traumatic brain injury patient, Army veteran Christopher Lynch.
The recovery does not stop after you get out of the therapy sessions, out of the classroom therapy. You go home and you keep doing it, you keep doing it, you keep motivation. It's the motivation that you need to have.
I was a little skeptical. I saw simplistic, repetitious movement in the therapy that he was doing. He had a mitt on his hand. It all made common sense to me, but I wasn't too sure. I still had my questions. Is this really going to work? 3 days into the therapy, Chris woke up in the morning and had a dream. That was the first surprising thing that I felt meant something. He hadn't dreamt in 2 years.
My brain, it felt like the brain was firing. It's like the more you work the brain, the more it heals itself in a way.
On the way home from therapy, we were between here and Montgomery, Alabama, and Chris automatically reached up and pushed the button on the radio with his left hand. And it blew me away. I looked at him and I was just extremely surprised by it. And he looked at me and said, "What?" So I knew he didn't actually have to think about pushing the button on the radio. It happened.
The main theme CI therapy. You either use it or you lose it. And if you've already lost it, that's okay. You can get it back if you keep trying.
Use it or lose it, in its simplest term, is at the core of our understanding of brain health. Use it or lose it is also a mantra for approaching any cognitive challenges that we might encounter, even when you don't expect it, as is the case with many people who have undergone chemotherapy treatment for cancer and were shocked to find themselves suffering from a condition called chemobrain.
I was diagnosed with stage 3 breast cancer 2 days before my 35th birthday. So a birthday present I was not expecting. You know, when you're told that you have stage 3 cancer, you make different decisions than you would, before then. So I started to do my research to find out, what can I expect to have happen? I knew my hair was going to fall out. I knew I was going to be nauseous. But beyond that, I wanted to know what is this like? And I, found out that there's this thing called chemobrain that might affect my cognitive abilities, which really scared me because I was young, I was active, to have to deal with any cognitive changes was, just salt in the wound.
Up until recently, it was assumed that cancer affects the body in 3 ways. Cancer can spread locally in the area where it grows. It invades the lymph nodes, and it can get into the lymph system or the sort of drainage system in the body. And then finally, it can get into the blood supply. But recently, people have figured out that there's sort of a 4th dimension called the cytokine phenomenon, or cyto for cell, kine for protein. And now it's pretty much routinely accepted that cytokines, or cell proteins, are produced by cancer cells as they grow, and they can affect remote parts of the body even where there aren't cancer cells or tumors growing. And it's believed that this may be implicated in some of the cognitive effects that occur with cancer and possibly with chemotherapy.
We know in some instances it can affect the way the neurons of the brain are wired, and that insulation on the wires that's so critical for shipping information around in the brain. And of course, it can also affect cell division, which in some areas of the brain, it's important that you have the capacity to generate new neurons. We know that's especially important in the hippocampus, and hippocampal function is critical to memory.
I thought I was losing my mind. Here I had cancer, and if that weren't bad enough, I couldn't, handle daily things. And it affected my enjoyment of things. I couldn't read a book. I couldn't get through a chapter of a book. So it was a little frightening, and I wasn't sure if this was going to last, because I have heard that chemobrain can persist in some people. I didn't know if I was going to be one of those people.
And we know from actually looking at the brains of people that have gone through chemotherapy that they are responding abnormally. And they respond abnormally in these critical centers that relate to memory, to remembering, and that relate to controlling the representation of information that's coming in rapid sequences or is played out in their actions in rapid sequences. So just like an older person, the brains of someone that's been through this chemical poisoning, and that's what it is, it's chemical poisoning, have slowed down and are operating much less accurately and are doing a much poorer job of supporting a good memory.
After I started chemo, I started doing the cognitive training and just felt like, okay, this is a formal program. Where I'd read, crossword puzzles help, but this was a very targeted, specific program to be doing, and I felt like, okay, this is just going to push me over the edge. It's almost like the insurance policy to make sure that everything is going to be okay.
We know that with forms of cognitive training, you can actually drive very significant recovery, and we've actually seen a number of wonderful cases of reversal of this condition in control studies. And it occurs because we're attacking, you could say, through intensive training, we're reversing the same kind of process that we reverse in any brain that's struggling cognitively to remember or to control our actions at high speed. These are improvable faculties, just like they're improvable in older people in general.
As we've seen, approaches based on the power of positive neuroplasticity can help people regain function, carve a path toward clearer thought, and possibly even minimize pain cycles. Psychologists also draw on the power of neuroplasticity with their approaches to bettering mental health.
We know that a form of therapy called interpersonal therapy, cognitive behavioral therapy, and psychoanalytic psychotherapy all reconfigure the relationship between departments in the brain for depression and anxiety. And the thing about using a talk therapy to do it, as opposed to using a medication, is you're just focusing on the problematic circuits in the brain. So a talk therapist, in a way, is like a microsurgeon of the mind when the therapy is going well, working just on the circuits, that's the memories and the learned behaviors that are problematic.
That kind of intervention takes a science fiction twist with a therapy designed to treat post-traumatic stress disorder. The therapy is a combination of precise talking therapy and virtual reality called virtual Iraq.
I think we've come to understand over the last 20 years that anything you experience or anything you learn results in some change in the brain. When you develop PTSD from an extreme experience in combat, the brain does change in some way. We had the idea that perhaps there might be some folks coming back from the war in Iraq and Afghanistan that would be suffering from some of the symptoms of PTSD, much like the Vietnam-era vets had gone through. And we thought about the idea of developing a treatment in virtual reality whereby you put a person back in the scenes in VR of the traumatic events that occurred to them, but in a very graduated way, and help them to process their emotional memories in a way where it's not just relying on imagination or reflective memory or anything, but rather putting them back in the scene so that it can kind of open up some of the things that have been bottled up. This actually is what we call exposure therapy.
Exposure therapy is based on a very old piece of psychology called learning theory, which basically talks about why we remember and focus on particular things and why things just sort of fade out of our consciousness. If we think about a very common everyday phenomenon where this happens, we stand every day inches from pieces of metal that are going by at 55 miles an hour and weigh 2,000 pounds. That should freak us out, but it doesn't because we do it every day. Our brain has just started to ignore the fear associated with that.
But in cases of post-traumatic stress disorder, or PTSD, it's the seemingly innocuous events and associations that can trigger fear and panic. Such was the case with Master Sergeant Robert Butler.
I had some issues and I actually talked to the chaplain, and he said, hey, I'd like you to go to the Naval Hospital and talk to, a psychiatrist, because you have some signs that I think might be post-traumatic stress disorder. And I scoffed him off, There's a lot of bad stigma with that still these days.
I noticed changes right away. Just was not as open. He was always the one that made you laugh, the one that would tell the jokes. Everybody loved being around him for that reason, and there was no more of that.
My wife would tell you I didn't laugh, I didn't smile. I wasn't interested in doing things that we used to do together, going out, just in a shell. I was at the store with her, and she said, hey, why don't you go grab some toilet paper? And I said, sure thing. I went over there, and there's like 100 kinds of toilet paper, and I found I was so overwhelmed I couldn't make a decision on what kind of toilet paper to get. She walked over there, and she's like, hey, you gonna get some toilet paper? And I was almost in tears because I was like, couldn't make a simple decision.
But seeking help was not an easy decision. Avoidance is one of the main difficulties in getting patients to deal with their PTSD.
The last thing you want to do is talk about what happened, because you've spent all this time avoiding it because it makes you feel bad, or you're just trying to put it behind you.
At the behest of his wife, he decided to seek help and qualified for a study of the virtual Iraq program.
Somebody with PTSD, say from Iraq, just the thought of sand at the beach may evoke a ton of memory that is painful. And what do? They avoid going to the beach. And when you avoid something, you get a sense of relief. All of a sudden, it's like, oh, and that reinforces the avoidance. So then it goes from the beach to driving on the freeway, going down the 405 to San Diego, and seeing a piece of rubbish by the side of the road, and all of a sudden that evokes a memory of where an IED had been hidden that killed your best friend.
The virtual ERAC treatment involves 3 sessions of traditional talk therapy with 7 sessions of the virtual reality exposure therapy. On the 4th visit, the patient is completely immersed in a virtual environment. Smells are released into the air, the platform beneath them moves, and the details of their described trauma are played out for them on the screen. The virtual environment is controlled by the therapist.
I'm not gonna lie, there was a couple of times they got me. They throw sounds in there. I mean, you don't know what's coming. I mean, they throw explosions and, you know, put smells in the room with you, and, you know, they try to put you in that frame of mind.
If you expose somebody to something they're afraid of or that they've been traumatized by, and you do it in a supportive environment where they can't get hurt, and you help guide them through their narrative of their trauma experience, that eventually the trauma memory almost becomes more boring than painful. I think anybody that goes to war is going to be changed. Now, are those changes going to make it so that you can't enjoy your life after the military, that you can have a rich and meaningful emotional life afterwards? Or are you going to live in chronic fear and anxiety and never feel a participant in civilian life afterwards? So what we do is not erase memories. We try to help people to process their memories and convert the emotional experience into something that doesn't put a harness on them for the rest of their life. They're always going to remember the bad times in war. I mean, that's always going to be with them. We're trying to equip people with coping skills so that they're not constantly being re-traumatized by benign things in civilian life that bring up a memory and cause them to shut down or run away or avoid. We're trying to help a person move on and carry on with their life. Not to erase memories, but to put those memories in a context where they feel safe again.
Something that I often say about this is the software itself does not treat the patient. The patient and the therapist treat the patient.
In terms of what goes on in the brain with a person with PTSD. Now, in the old days, people cast aspersions on the diagnosis of PTSD, saying, oh, well, maybe it's just cowardice or weakness or any of that. Now, with modern brain imaging, we can get a little window into the soul, so to speak, and we can see what goes on in the brain when people are presented with emotional stimuli.
Areas of the brain, the amygdala and the frontal lobes, were implicated in fMRI studies. The amygdala controls the fight-or-flight response in the limbic system of the brain. The frontal lobes act as a control mechanism on the limbic system.
With people with PTSD, you put them in an fMRI system and you record their brain functioning, and you present, say, for a quarter of a second, 250 milliseconds, an emotional face, like you know, an angry face or even a happy face, and then follow it immediately by that same face in a neutral pose. When you ask a person what they saw, they'll say, oh, a neutral face. They don't consciously perceive the emotional face because it's masked by what immediately followed. It was shown for such a short period of time that the perception is of the neutral face. But the brain sees that emotional face. And what you see with people with PTSD, and a number of studies have replicated this, is that the amygdala is overactivated and the frontal lobes are underactivated. Now we've got the ultimate stimulus delivery mechanism, virtual reality, and one of the ultimate response measurement systems looking into the brain with fMRI and other methodologies for brain imaging. Now you've got great tools for studying brain process.
We've looked session by session at physiology, and we have seen that people's, in other forms of virtual reality treatment and other forms of therapy, physiology tends to improve as well. But the gold standard is still what the patient tells you. The goal is to allow people to feel better and to report that their lives are better.
The active therapeutic process does result in some brain change or plasticity, taking advantage of the plasticity of the brain, because I think the brain is constantly changing and growing based on its experience. Therapy is an experience.
I'm definitely sure now that I've gone through the treatment and I've got some ways to cope with it, that was the healthier decision, that I'll live a healthier and more happy life.
Not all solutions that tap into the power of plasticity are filled with high-tech imaging and the latest in computer technology. As we age, neuroscientists believe maintaining an active and engaged social life is also important. At the Intergenerational School in Cleveland, they provide a plan for positive aging that has found remarkable success in keeping minds youthful and in bridging the generation gap. Their school challenges the expectations of age while enhancing the lives of the next generation.
We need to focus on the positive aspects of aging. And in the Intergenerational School, we talk about wisdom. We talk about the fact that if we are to survive as a species, and this is a time where we can legitimately ask that question, the wisdom of the elders becomes an important part of our surviving.
The school partners adult mentors and youth in order to help them co-learn, exciting children with the educational process and keeping adults engaged. Through the process of co-learning, they utilize each other's strengths.
Some of our older folks, well, they're not so good at remembering your name, but aren't they great at listening to you read a story or, reading a story to you? So, we teach children, well, so-and-so it might be hard for them to hear you. So that's why they might ask you to repeat things. So this is what you need to do in that situation. Mrs. Kelsey is just wonderful. She has to come with someone else. She would not be able to come independently.
I don't remember very much of this. We don't do it very much, do we?
Yep, you come 3 days a week.
Oh my goodness, I must be losing my mind.
Well, you don't have a good memory, but you're perfectly good at helping kids read. In fact, you're very good at it. They really like you.
When she is here, she is totally in the moment with the child, and they're both just having a great time.
Once you've met one person with Alzheimer's, you've met one person with Alzheimer's, because the condition is so variable in different people that I honestly think that rather than thinking there are 25 million people around the world who suffer from this one disease, there are 25 million people or so around the world who suffer from a variety of processes, each of which is individualized for them, that constitutes, unfortunately, a severe case of brain aging.
If someone has a cognitive decline of some kind, wouldn't it make sense to help them on the front end to stay engaged? And what would a person have to do to stay engaged to keep them having a fulfilling life and keep them as high functioning as possible? And why would you just say, okay, that's over, and then let it go?
Scientists have looked in programs in which older individuals have been re-engaged in the community, and have actually looked in their brains, and they've seen their brains have changed for the better. Their brains are more powerfully engaged attentionally and in their memory. Their brains are positively operating more effectively, and the individuals are operating with greater confidence. And all this is reflected by brain change. When something really matters to you, that is an environment for constant and continuous learning, that really is important to you, and every day you wake up with your eyes wide open, ready for action, that's a very good and healthy thing to do for your brain.
I do have some memory issues, and what I've noticed is that because I'm so patient with the children, I tend to be more patient with myself. And they're very accepting. They know I have memory issues. I have a terrible time remembering names, and they're patient with that.
People with significant memory problems can still participate in the activities of the school, and we have evidence that that is helpful to the children, and it's also helpful to them in keeping their minds cognitively vital. The point, I think, is that even if you have some short-term memory problems and perhaps difficulty reading adult books, you can still read children's books or listen to the child read to you, and you can also share with the child the stories from your own life, because your long-term memory is less affected. And so the children get to read with an adult who is interested in them, who helps them learn to read, and also helps them put that reading into the context of real life.
We interviewed the seniors. We had one senior buddy, and they asked them questions about their life, and they wrote down their history. And so after a school year of doing this, so 7 or 8 times, we created these books for them, sort of like scrapbooks of their history. The students drew pictures, and then they presented these books to the seniors and their families, and it was very moving for a lot of their families to read their memories that these people had, because hearing the same questions month after month, a little bit more comes out. What I really liked to see was actually the students' interaction with them. They're sitting there, students would be on the floor with them, and they'd sit there for 45 minutes listening to the seniors tell the same stories month after month, and they wouldn't move. I have kids who, an extreme case of ADHD, who could not function in the classroom without an aid. This child, and I was really nervous bringing him here, this child sat there for 45 minutes, was polite, was kind, was considerate, didn't say, you told me this story last month. Nothing, just listened. The kids get transformed just by interacting with seniors, and that was amazing to me, just to see that, and it never fails.
The very word retirement kind of means that you withdraw, that you step out of the daily course of life. Now, obviously, as you get older, you both deserve and perhaps are more comfortable with less engagement with certain activities of life. But the disengagement is ultimately, I think, very disadvantageous to the person, because they themselves tend to become sedentary, less physical exercise, but it's also a disservice to society. The intergenerational school is based on this notion that we're all learning all the time, and that the best kinds of learning experiences are experiential learning or learning in service of other people. So we focus on the commonalities, the things that we create rich environments for everybody.
When you start thinking this way, everything becomes intergenerational. For example, we had a ballroom dance class this year, and I kept thinking, okay, why do we not have, seniors here ballroom dancing with the kids? I mean, there's no end to the possibilities if you just are open to thinking about learning as a lifespan activity.
The fact that the brain changes with experience is not news. Plasticity at the level of behavior and thinking is well known, and that has, as one of its biological substrates, brain changes. So I think we celebrate plasticity, we celebrate adaptability, we celebrate resilience, we celebrate the ability of people and communities to change. We are in a world in which we are not only challenging the very notions of brain aging, but of aging itself. I think aging is not something that you start when you're 65 or you're 85. It is a lifelong task that we all have to realize that we have a limited time on this planet.
Brain plasticity isn't just for people that have big problems. Brain plasticity is actually for everyone. I mean, we see examples of big miracles where people in great difficulty basically have great recovery. I mean, those are fabulous stories, and we wouldn't want to belittle them, or, we love those stories. But brain plasticity is for everybody. It's for every individual, because every one of us can use this resource to be stronger, better, operate more effectively, be more accurate in our operations, and basically be healthier, and look forward, perhaps, to having our brains live as long as our body. I mean, that would be a blessing to maintain our independence to the end for any one of us. So I look upon these as the small miracles. To transform a life, to go from where you are, that is to say, on a downhill slope, to stopping that downhillness and going on an even keel and maintaining something closer to and growing again. We have the potential to grow again. To my mind, that's an ideal life.
Using plasticity that is in all of us can save us in extraordinary situations or provide us with the small but important miracle of changing how we age. As we've witnessed, scientific advances are dreams made real. The pioneers on the frontiers of brain fitness are constantly forging forward, using new technology and new science to push the bounds of what was once seemingly impossible, allowing us the ability to think faster, remember better, and live a fully engaged life.